Lesson 6.4, Similar and Congruent Figures. Similar figures are two figures are similar if they have the same shape but not necessarily the same size. We represent similar by using this notation. Corresponding parts of figures or sides or angles have the same relative position. Congruent figures have the same shape and the same size. Congruent is represented by this notation, an equal sign. Let's try that again, an equal sign with a swivel on top. Please watch the video on congruencies and similarities.
It's easy to get wrapped up in a movie and focus in on just that one shot. Pleasing the audience's eyes is hard work. There's more to it than pointing a camera and filming a scene. Each image is carefully composed, even when countless frames flash before our eyes. Believe it or not, geometry is a main part of the cinematographer's toolkit for creating beautiful images. To do it, they use principles we can understand using mathematical concepts of congruence and similarity. Congruent forms are exactly the same shape and size. The ratio of sizes of corresponding parts from one to the other is 1 to 1. Congruent forms are also similar. Similar forms are the same shape. Their corresponding parts have the same size ratio. The ratio determines the scale of one with respect to the other, so a shape's proportions are preserved. This larger triangle's dimensions are twice the smaller ones. The ratio is 2 to 1. Cinematographers often use a method called the rule of thirds. They divide the screen into 9 rectangles and place an image off-center at an intersection. This practice is considered to make the images more interesting than placing a subject directly in the center. These rectangles are all congruent with one another and similar to the entire frame in the mathematical sense. Similar forms are the same shape, and corresponding sides all have the same ratio. Therefore, two objects of different sizes but the same shape can be considered similar since their proportions are the same. For example, one small rectangle within the larger frame is similar to the largest rectangle. This is because all corresponding angles are the same, and each side of the smaller rectangle is 1/3 the length of the corresponding side of the larger rectangle, and the ratios of the length of the short side to the length of the long side are equal for both. Two small rectangles are congruent because not only are they the same shape, but since the sizes of corresponding sides are identical, they're also exactly the same size. Now that's a great shot. This looks like the Capitol building, but it only stands around 7 feet tall. It looks like the same shape, but it's definitely not the same size as the real Capitol building. This is Legoland's Mini USA. It has a model version of Washington, D.C.'s monuments, including the United States Capitol building. The real Capitol Statue of Freedom alone stands 19 feet 6 inches tall. Similar forms are the same shape, and corresponding parts have the same ratios. This ratio determines the scale of one object with respect to the other. Proportions within a shape are preserved. Congruent forms are similar, but always with a ratio of 1 to 1. So that's why they're the same shape and size. Now back to our Capitol. Parts of its form are similar, but not congruent to the form of the corresponding parts of the actual building, since it is smaller than the original. Measurements can reveal that it was built using a scale of 1 to 20, meaning the relationship between the model and the original. Even if it's not the real thing, it's still a capital experience. American ideals, liberty, and justice. So, great care is taken in making new flags. Standard flags usually are geometrically similar to one another. That means flags of the same size are also congruent. Similar forms are the same shape, and their corresponding parts have the same ratios. This ratio determines the scale of one with respect to the other. Proportions within a shape are preserved. Congruent forms are similar, but always with a ratio of 1 to 1, so that's why they are the same shape and size. This smaller flag is similar to the larger one waving in the wind, because it has the same internal ratios and angles. Compare the rectangle shapes and even the stars and stripes. Their corresponding sides all have the same ratio, even though one is much larger than the other. The smaller flag has a width of 2 feet and a length of 3 feet, and the larger one has a width of 4 feet and a length of 6 feet. In both, the ratio of width to length is 2 to 3.
You can see on the flags that the smaller flag has a length of 3 feet, where the larger flag has a length of 6 feet. 3 times 2 is 6, just like 2 times 2 is 4.
The flags show the proportion of 2 to 3 equals 4 to 6, the same as 2/3 equals 4/6. When the overall size of the flag is proportionately increased, here it's doubled, the star field's length and width are similarly increased as well. The height of the star field in all flags is the height of 7 stripes, while the height of the entire flag is always 13 stripes. And every measurement on the larger flag here is twice the corresponding measurement on the smaller one. Not only are internal ratios preserved, but the ratio of a measurement on the large flag to the corresponding measurement on a similar small one is always the same, here 2 to 1. These two medium-sized flags are congruent. They have identical forms. The corresponding measures have a proportion of 1 to 1. If we put one on top of the other, they match everywhere. That's one Star-Spangled Banner.
Properties of similar figures. Triangle ABC is similar to triangle DEF. Here's triangle ABC, here's triangle DEF. Remember, similar is the same shape but different sizes. Corresponding angles of similar figures are always congruent. Remember, congruent means the same. Angle A is congruent to angle D. That means they're going to have the same measurement, where angle B and angle E are going to have the same measurement. That's why they use this little arc to denote the same measurements. C and F are going to have the same measurement too, and you can see that's 90 degrees. The ratios of lengths of corresponding sides of similar figures are always equal, meaning whatever AB is, which in this case is 5, over DE, which is 10, that is set equal to BC. BC is 3, EF is 6. Same thing with AC is 4, DF is 8. You can see all these fractions simplify to 1/2. In example 1, identify corresponding parts of similar figures. Remember, corresponding angles and corresponding sides. The shape doesn't really tell us too much about what's corresponding. However, when they give you the triangle XYZ, that's telling us what's corresponding to triangle UVW. The first letter, or the first angle, is X, just like the first one is U. So I can say angle X is corresponding to angle U. Let me just show you. The second letter is Y and V, so those are corresponding. The third letter is Z and W, and that's corresponding. Again, we can do the same thing with our sides. XY is the first two letters of the first side, where UV is the first two letters of the second side. Oops, excuse me. Name the corresponding angles and the corresponding sides of STUV, which is similar to WXYZ. Again, look at the order in which they put the letters. Pause the video and try number 1. In example 2, we are finding the ratio of corresponding side lengths. Given ABCD and QRST, find the ratio of the lengths of the corresponding sides. When we write a ratio comparing the lengths of a pair of corresponding sides, we then need to substitute the lengths of the sides and simplify. First of all, you need to find a side that is corresponding. So you know A and D, first letter, last letter, is corresponding to QT. AD is 8, QT is 10. So 8 over 10. Simplify, 4 over 5. The ratio of the lengths of the corresponding sides is 4/5. Again, you could pick any side that was corresponding. Like I could have done BC, which was in the middle of the order, and then RT, again that's actually still 8 over 10. I could have also done ST and CD, and again that should simplify to 4/5. For checkpoint 2, you are given FGHJ. This is a quadrilateral, and it's similar to KLMN. Find the ratio of the lengths of the corresponding sides. So let's just pick FG, which is 8, and that's corresponding to KL, which is 6. Simplify. Your answer is 4/3. The ratio of lengths is 4:3. In example 3, you're going to find the measure of congruent figures. Remember, congruent means the same shape and size. We want to find the indicated measure. First one is KL. I know KL is the first two, so I want to go to DE. That's the same as DE. So here's KL. It's the same as DE. It's corresponding, or the same, which is congruent. So if DE is 8 feet, and it's the same as KL, KL is also 8 feet. Find the measure of angle L. Well, here's angle L, it's the second letter, so the second letter is E. E is 111. Because angle E and angle L are the same, angle L is also 111 degrees. Pause the video and given a triangle ABC, which is congruent to triangle LMK, find the measure of angle L. Pause the video. Angle L is in the first position, so it's congruent to angle A. Angle A is 58, so angle L is 58 degrees.